This is example 29 in our differentiation topic, and we're looking at logarithmic differentiation. It's good for dealing with functions where we've got powers, even powers of powers as we've seen. It's also good where we've got terms that are multiplying together, or there's a fraction with terms dividing each other, because we can use some of our log rules to simplify that. So let's have a look at this question here. Let's see if I can bring that to the side here. We'll try and do it on one screen. So we want to, before we differentiate, we want to kind of simplify it using some of our log rules. So we take the natural log of both sides. Let's do that. So we can say the natural log of y is equal to the natural log of 3x plus 2 squared over square root of x plus 4. Now, you may already know that if in dealing with log rules, that if you've got the log of a over b, we can actually write that as log of a subtract the log of b. Or usually we use it the other way around, where we're simplifying a difference of log terms by writing it as a fraction, but we can also break it up or work the other way. So I can actually rewrite that right hand side by saying we've got the natural log of 3x plus 2 squared, subtract the natural log of square root of x plus 4. I'm going to write that as a fractional index rather than with the third form, because that's going to help us. So the next, we've got log y still on the left. The other rule which we're going to use is the idea that if you've got the natural log of a to the power b, as we've found out already, that we can move the power to become a coefficient. That becomes b times the log of a. So we're going to employ that particular rule and move these powers of 2.5 to become coefficients. So it becomes 2 times the natural log of 3x plus 2 minus a half times the natural log of x plus 4. Okay, we've still got the natural log of y on the left. That's us simplified it as far as we can go with our log rules. So what we then want to do is we want to differentiate both sides. Okay, and I'm just going to write that down. Sometimes it's good to explain that. A lot of people just do it and expect everybody to know that's what happened. I tend to like to explain what's going on. That's the fact that I'm about to differentiate both sides. So the derivative of, one of the reasons why it's good to put d by dx here is because it reminds us that we're differentiating a function in y with respect to x, and that means that we're doing implicit differentiation. So log y becomes 1 over y in the normal differentiation process, but because it's a function of y, we need to multiply it by dy by dx, which is our implicit differentiation. We don't need to do that with the right hand side because it's all functions in x. So the first term here, we've got 2 log 3x plus 2 differentiates to 2 over 3x plus 2. So the log 3x plus 2 becomes 1 over 3x plus 2. We've got our 2 constant. We have to multiply that by the derivative of the inside function, which is 3. The second one, we've got a half as our constant term. So the 1 is going to be our numerator. I know the 2 is going to be on the denominator. Differentiate log of x plus 4. It becomes x plus 4 on the denominator, multiplied by the derivative of the inside term, which is 1. So I can just tidy that up, refresh it by saying that 2 multiplied by 3 is 6. So my first fraction is that, second fraction becomes that. So I'm going to go ahead and simplify this fraction here into 1. If you look at the denominator, we've got 3 factors, none of which are common. So we're going to have a denominator with 3 factors in it, and I'm just going to write it out once rather than 2 separate fractions. I trust that you'll get the idea here. So I've got 2 times 3x plus 2 multiplied by x plus 4. So the first numerator is going to be the equivalent of the first fraction, 6 over 3x plus 2. So I would have to multiply the 6 by the other 2 factors, which is 2 times x plus 4. You do it in a different colour. So the 6, multiplying the 6 by 2x plus 4, we get 12 times x plus 4. Okay, and then I'm going to subtract from that the what we get with the second fraction. So we've got 1 here. Our denominator is 2 times x plus 4, so we'd have to multiply top and bottom by the other factor. 1 times 3x plus 2 is just 3x plus 2. Watch the minus sign there, so keep this expression in the brackets so that when you multiply it out, everything is multiplied by -1. And we can simplify the numerator. We've got 12 times x and subtract 3 times x, which is 9x. We've got 48, 12 times 4 is 48, subtract 2 is plus 46. And we're dividing that by our denominator, which is 2 times 3x plus 2 times x plus 4 all over. I'm going to put a wee line here so that it looks nice and neat. There we go. And on the left hand side, of course, we've still got our 1 over y times dy by dx. Okay, so we're nearly there. What I'm going to do is we're going to take this, save me rewriting, I'm going to put it over here so I can keep it all on the one screen. So what we need is just dy by dx on the left. As we can see here, we've got, we want this, which means we have to multiply both sides by y. Okay, so we need to multiply by y and multiply by y so that they cancel out. So what have we got? We've got dy by dx is equal to y multiplied by this fraction. Well, we know what y is because it's over here. So we can write that in as 3x plus 2 squared over, I'm just going to keep it in index form just now for reasons which will become apparent, multiplied by, well, our big fraction here, and I'm going to keep using my line tool. So we've got 9x plus 46 over 2 times 3x plus 2 times x plus 4. Lovely. Now we can actually simplify that. Can you see how? We've got 3x plus 2 squared here, and we're multiplying these two fractions so we can cancel out or simplify anything from the numerator and denominator. We've got 1 3x plus 2, and we can divide through by 3x plus 2 to make that to the power 1. We can also link up these two terms here because we've got x to the power 4 to the half, so x plus 4 to the half, and we've got x plus 4 to the 1. If we multiply these two terms, we're going to get x plus 4 to the power 1.5, or 3 over 2. So the final answer, and this is where I'm going to finish, dy by dx is equal to, we've got 3x plus 2 to the power 1, we've got one lot there, multiplied by 9x plus 46. That's my numerator, and my denominator becomes, all I've got really left is the 2. So I'll go ahead and I'll write the 2 in, and I've got x plus 4 to the power 1.5, which of course we write as 3 over 2. And that's my final derivative of the original function. Made possible using logarithmic differentiation, a bit of algebraic fractions, and a wee bit of simplifying. So hopefully that makes sense. It's a nice problem, and you'll find there are other questions like that we can differentiate using logarithmic differentiation. Okay, hope that's been helpful.